VJTI was established in the year 1887 and is upholding its proud legacy of over a century filled with brilliance and educational prowess. Furthermore, it has thrived in nurturing the brightest minds of the society. Technovanza has always been the prime platform where the flame of expertise has been meritoriously passed on to light more torches. Pioneers of diverse fields, including Dr. APJ Abdul Kalam, Mr. Ratan Tata, Gaur Gopal Das, and many others have graced Technovanza with their presence, while progressively illuminating young minds to new areas of interest. Behold, because today we are elated to add a truly inspirational name to our glorious list of dignitaries. Our guest today is the phenomenal Mr. Tanmay Bakshi. Tanmay Bakshi is a Canadian 17-year-old homeschool graduate, TED and keynote speaker, Google developer expert for machine learning, advisory software engineer at IBM, visiting professor at University in Tokyo, best-selling author, media personality, and YouTuber. He builds technology that augments human lives and aspires to empower at least 100,000 people with the technology they need to change the world. At age 5, his dad's laptop sparked his passion for code, and by age 9, not only did he already have his first iOS app published to the App Store, but he was also the youngest app developer in Canada and was named Newsmaker of the Year in 2013 by the Toronto Star. In the last 8 years, he's addressed over 300,000 executives, developers, and students in over 30 countries for organizations including the United Nations, Apple, Walmart, Microsoft, KPMG, Linux Foundation, and Amazon on topics such as the truth behind AI and the importance of making technology accessible to all. Augmenting songwriters, recognizing people by their heartbeats using ECGs, decoding mental states from EEGs, and tracing function calls faster than ever before are just a few of the ways he's applied next-gen tech. Tanmay has been featured in international media such as the Toronto Star, Forbes, Bloomberg Businessweek, Entrepreneur, the Huffington Post, the Wall Street Journal, the New York Times, CNBC, CBC, and many more. Tanmay, this small introduction wouldn't do enough justice to you. You have blended the eloquent qualities of hard work and persistence with absolute sublimity, which can never be unseen. We are truly honored by your presence today. Tanmay will be sharing with us his expert outlook on the next big thing in technology. We will also have a Q&A session after the lecture. So without any further ado, let's be a part of a conversation of our shared future under the guidance of Clearly the Best.
Thank you very much, Urvi. I'm very glad to be here today and glad to get to share my thoughts with everybody. You know, I really wish I could have been there in person. I feel like that would have been so much more fun, get to actually interact with all of you, you know, in the real world. But I'm sure that hopefully next year we can actually be in person again. But no, it's great to be here even virtually and get to hear from all of you as well. Again, sort of my goal here is that I want to not only share my thoughts on the next big thing in technology, but also get your thoughts, right? I want to get everybody's thoughts. I want to hear what your questions are, you know, what you think. So make sure, you know, everybody put that in the live chat, any questions you might have, you know, any thoughts you want to share, and we'll be sure to get to that as well. But to start off with, though, there are a couple things that I want to share. And so I'd like to dive right into that. I'm going to go ahead and share my screen with everybody, and let's get started. We're going to have a lot of fun today. There's some pretty interesting examples, if I do say so myself, that I'd love to share with you, including, you know, some of the most unique music I can practically guarantee you will have ever heard, and also some pretty fun projects with biometric authentication and so much more. Before I start, though, I mean, once again, you know, the reason that I'm here is because I'm incredibly passionate about technology, right? And I've always been really passionate about technology. Ever since I was 5, I've been absolutely hooked to, you know, using the power of technology to do things that are fun and that can now, you know, actually solve real world problems. But it's also, you know, apart from just creating technology that I'm really passionate about, I'm also really interested in helping others build their own technology as well, right? Enabling others to have the resources to build their own technology. And so that's why I've been working towards sharing whatever it is that I learned through numerous different media, including through, you know, interactions like this one today. And so as a matter of fact, once again, a huge thank you to the team at the Technovanza for putting together this event, coordinating all of this to happen virtually and inviting me to be a part. Super excited. And as I mentioned, I love to share my knowledge through a bunch of different resources, including my YouTube channel, Tanmay Teaches, as well as the 4 technology books that I've authored, ranging all the way from coding from scratch using programming languages like Swift to coding complex application backends in languages like Go. Now, really, what I've been super passionate about for the past couple of years, about 6 years now, is one particular technology. And that technology is what we would call artificial intelligence, right? And you probably know this. But here's the thing about artificial intelligence. I think that AI is by far the most misunderstood technology in the world, right? It's super, super powerful. It's one of the most powerful you can get, but it is also incredibly misunderstood. As a matter of fact, I think it even goes down to the verbiage, right? I don't even think we should be calling it artificial intelligence necessarily. I think, behind a lot of the modern advances in AI, we really just have machine learning technology, and AI is more of a user experience term. And I want to get a little bit deeper into that. But in order to sort of understand why I'm so passionate about AI and how this even got started, I think it's important we take a couple of steps back to about 2015 when I was 11 years old. And that's when I stumbled upon Watson and how IBM's Watson not only played, but also won the Jeopardy game show against the 2 best human competitors on the show. Now, sometimes it can be hard to wrap your head around just how fascinating that is. Jeopardy is an incredibly complex game show, right? With Jeopardy, you're dealing with, trying to understand incredibly complex clues that even humans take a couple of seconds to just comprehend. And then you're relating that to such a vast knowledge base, trying to find a response in the form of a question. It's incredibly complicated. There's puns, riddles, and wordplay. And yet, Watson, a computer system, could not only comprehend those clues, but also come up with responses in real time. That is absolutely incredible. And so I wanted to know more about how AI works and how this machine learning technology enables us to implement such complex applications. And so I delved deeper into the world of machine learning technology and AI through Watson and through my own custom techniques. And I feel like as I've built artificial intelligence technology, there's one really simple way to describe what this technology enables us to do, right? And what it is that it takes certain human capabilities, right? Certain things that we are really good at, and it enables us to offload some of those tasks to computers, right? Things that were never possible before to be done on technology. Because if you think about it, humans have a bunch of capabilities that we take for granted. Right? So natural language, for example, is incredibly complex. It sets us apart from practically every other animal, and we can comprehend it. We can synthesize it. Similarly, we can look at the environment around us and understand what's in it. We can automatically, for example, you can look at me on your screen and understand that I'm not physically present there in your environment, but that this is a scaled down image of me. We have this incredible auditory processing capability. You can understand what it is that I'm saying through audio, right? We have these incredible capabilities, but then when you take a look at the world of computers, you start to realize that they are a lot more limited, right? The only thing that computers can do is process mathematical operations. That's it. That is the extent of their capability. That's not to say it's not useful, right? When you run billions of mathematical operations a second, you can do some incredible things, right? All of our technology today is based on mathematical operations, and we're using it absolutely everywhere. But that means that the technology that we use is fundamentally limited in the sense of it can't understand complex data like natural language or visual data. But with more complex modern mathematical algorithms like machine learning technology, this suddenly becomes a possibility. And because of this brand new sort of possibility, machine learning has been voted as the most disruptive technology out there today by over 72% of organizations. Right now, let that sink in for just a second, right? 72% of organizations think that machine learning is the most disruptive technology out there. But why though? right? Why? I understand that it opens up this whole new world of possibility, but why? What is it about machine learning that leads us to that 72%? And there's a quote that I think summarizes it pretty well, and I want to share it with you. It's because of the effect it can have on existing processes and the way people will work. Okay. I'm not going to tell you who said that just yet. All right. I'll get back to that in just a couple of minutes. But just remember that this is a valid reason as to why machine learning technology is so impactful. And to understand what this quote means and what the sort of role of it is, I think we should take one more step back, right, and go a little bit closer to the fundamentals, the foundations of technology. You see, all of technology, right, everything that we do with technology, we use it as infrastructure, right? That is what is so incredible about technology, is that we have effectively built out an industry that is not only its own industry, but also acts as the infrastructure for every other industry. Think about healthcare. Right? Today, we have the power of super advanced technology like MRI machines that enable us to provide more advanced healthcare. Think about education. We can provide more personalized education, more interactive education, even in the classroom, by using the power of technology. Think about agriculture and how we have more intelligent, more modern, faster, more efficient ways of doing agriculture or operating within that industry. Think about entertainment, right? Even down to the way that movies and TV shows are produced, right? Disney, for example, they're phasing out green screens. Now we can actually render scenes in real time in these sort of domes of screens using game engines. It's pretty incredible. And in finance, right? We're able to trade with millions of people in milliseconds using the power of technology. This is something we could have never done before. And if you look across all of these different use cases, you start to realize that there's places to apply a bunch of next generation technology, but there's also a bunch of next gen technologies that don't fit. Don't is the key word there, right? So think about agriculture, right? In a specific, say, agriculture use case where you're analyzing a lot of data in real time using machine learning, maybe you don't want to use the cloud as much, right? Because you want low latency, you want things happening on the edge quickly. Maybe you don't even have network connection. In that case, maybe the cloud isn't that useful. Or maybe in the field of entertainment, blockchain isn't as useful because you don't really need a blockchain if you're recording a video in a dome, right? And similarly, maybe in education, maybe IoT isn't as useful as it would be in a different use case, like maybe a healthcare or maybe a finance. And so you start to realize that across all these different use cases, there's certain technologies that don't apply. But here's the thing. Across every single one of these use cases and domains, there is one technology that is practically universally applicable, and that is machine learning. Now, why is machine learning so universally applicable? Why does every one of these 5 examples have, a specific use case for machine learning? And I'm not cherry picking here. I didn't choose these 5 examples specifically to show you what machine learning can do. I'm just showing you that in general, machine learning can be applied everywhere. And the reason for it is because at the end of the day, all machine learning is, right? If you strip away all the hype and what people say about artificial intelligence, you realize machine learning is just a bunch of data analysis. That is what machine learning boils down to. And here's the thing: we're generating data absolutely everywhere. It is incredible how much data we are generating. And with machine learning technology, we have the capability to now unlock insight and find out patterns within this huge amount of data that we're generating, whether it be structured or unstructured. No matter how massive that data might be, we now have the capability to unlock an understanding, a deeper understanding of that data through technology. Now, I'm excited to say that I've built a bunch of different projects that leverage the power of machine learning technology and this data analysis capability. And I'd love to go ahead and show you a couple of those now that I think you'd be really interested in. And I want to start off with a really fun one, and it's called HeartID. Now, as the name suggests, the point of HeartID is to enable a brand new form of biometric authentication. In particular, I've built deep neural networks that can recognize people based on the way that their heart beats, particularly based on the electrical activity of your heart. Kind of like how you can unlock an iPhone with Face ID, you can unlock systems that use HeartID with your heart's electrical activity. Now, the way that it works is there's two phases, of course, kind of like another biometric authentication system. First of all, there's production training, where you provide my system that I've already built with a bunch of electrocardiogram data of users that you know the profiles of. And then what it does is it extracts unique features from that electrocardiogram and stores them in a database. Then, once it has those features, now you can provide new data in the production inference stage that it might have never seen before, and they can help recognize whether that new electrocardiogram comes from a user previously in the database or not. And by implementing a system like this one, you can effectively have heart-based authentication. Now, if you take a look at the raw features coming out of the neural network, the sort of general gist of the way it works is the more similar two sets of features are, the more likely that the original electrocardiogram came from the same person. So, for example, if I plot out features of the heartbeats of both me and my sister, you realize they look very different, which makes sense because we're not the same person. However, if you were to take more electrocardiogram from me and more from my sister, you should see not the same, but incredibly similar feature graphs telling me that, it's very likely that the electrocardiogram from both those recordings came from the same person originally. Now, there's some pretty fun things you can do when you can authenticate through electrocardiogram. As a matter of fact, I asked my friends Raquel and Simone for some help at testing out HeartID. Now, you might be wondering, why did I call on the two of them to test out this project? Well, it's because they are incredibly rare. Watch this. They have this super, rare ability to be able to trick Apple's Face ID. Right? So taking a break from HeartID for a second, Raquel and Simone have the ability to trick Face ID on the iPhone. So for example, if Simone pulls up her phone and tries to unlock her phone with Face ID, it works perfectly fine. But when she hands it over to her sister can unlock her phone as well. That is an incredible capability. Super rare, especially because if you take a look at Simone's settings, there is no alternate appearance set up. Right? This is not based on a Face ID alternate appearance. They really are tricking Face ID here. So of course, when I saw this, I was just absolutely fascinated, and I had to see if my system, HeartID, could actually authenticate and sort of differentiate between them. And so I'm glad to say that it did work. If I capture a couple of seconds of data from Raquel using my electrocardiogram setup, my system can correctly identify her as Raquel, and similarly, a couple seconds of data capture from Simone, and my system can correctly identify her as, Simone. And that is the power of HeartID biometric authentication using electrocardiogram. Now, I personally think that is an incredibly fun project, and it just goes to show, what you can do with the power of deep neural networks when they're applied to analyze data, incredibly complex data like this. And, I've worked on a bunch of different machine learning projects across tons of different use cases, including, ones like HeartID here. But one thing that I've always really been passionate about, applying machine learning to is language. Language in general really fascinates me because it is really what sets humans apart, right? It is the perfect example of what makes our intelligence so unique, right? It enables us to have the sort of medium with which to communicate our creativity. And applying machine learning to understand language, in my opinion, is incredibly fascinating. Now, to understand why language is something that's so fascinating to me, there is one example that I'd love to share. All right. As a matter of fact, a quick game that I want to play. Actually, you know what? Let's go ahead and play this with everybody in the YouTube live chat right now if there's not too much of a delay. I'm going to show you 3 shades of the color blue, and you need to tell me which one is different, right? So there's 2 that are the same, there's 1 that's different. In this case, it's pretty obvious which one is different, right? If you go ahead and I have the YouTube live chat loaded up here. I feel like there's a bit of a delay, so it wouldn't be as fun for you to sit and watch me wait for your responses. But, everybody, for just so we can see what you think it is, put your guesses in the live chat. What do you think is the different color? All right. In this case, obviously, it's blue. Pretty easy. You didn't need me to tell you that. Let's get a little bit harder. Okay, what about now? Which one's different? Couple seconds. You can probably tell that the different one is C. Okay, let's move on. A little bit harder now. Which one's different? Give it a couple seconds. And it's B. All right, let's do one more. Now, I could just keep getting harder, but I'm not going to, bore you with just getting harder and harder here. I will get to the point, but in this particular case, the different color is A. Okay. Why did I just play this little game, right? Why did we go through which color is different? Well, it's because, did you know that you are statistically more likely to be able to tell between more similar shades of the color blue if your native language is Russian? Why is that, you may ask? Well, it's because there are just more words for the color blue in Russian. And so your brain from a young age is more primed to tell the difference between blues. And therefore, you quite literally see the world differently. The way you see things and your sensitivity to shades of colors is changed by the language that you speak. So it's not only the brain that helps sort of form and mold language, but it also goes the other way around, right? Language helps mold the brain as well. And that is incredibly fascinating. As a matter of fact, after we sort of started to communicate in this sort of complex natural language, humans sort of backtracked a little bit and we thought, can we apply structure to natural language now? And so we invented things like syntax rules and grammar. And now we have weird edge cases in the world of language, where we have sentences like colorless green ideas sleep furiously that make absolutely no sense and don't really mean anything. But at the same time, there's technically nothing wrong with the sentence syntactically, right? Like if you were to try to structure it into a syntax tree, you technically could, and there would be nothing wrong with it. But at the same time, you can tell that it makes no sense. Language is super complex, right? That's what it boils down to. And I have been really fascinated by applying machine learning to the world of understanding language. And before I sort of get into what that intersection is, there is one thing that I really quickly want to share first, and that is that there are all kinds of misconceptions around where artificial intelligence technology is applied, right? There are people that think artificial intelligence is meant to simulate human intelligence, but that's not even remotely the case, right? Artificial intelligence couldn't be further from how human intelligence operates. There are people that believe AI is meant to replace every human job and make it so technology is doing everything for us. Once again, not even remotely the case. There are certain sections, certain fields that are going to be replaced, and there's a lot that we're going to invent and a lot that still require that unique human creativity. And even further, there are people that believe AI is meant to surpass human intelligence. But once again, we're not doing that. We're not inventing, general purpose reasoning to the point where, human intelligence is obsolete. That is not what our goal is, and that's not what this technology is meant for. Yet, despite the fact that that isn't true, there are all kinds of articles and journals, all this kind of research into replacing humans with the power of artificial intelligence, right? For the media, for example, you see news articles just like this one all the time. Can artificial intelligence replace songwriters? Study on AI lyrics suggests it's possible. But that's not how it works, right? Machine learning, artificial intelligence technology can't replace songwriters, partially because, in the world of art, the value of art is, in large part dictated by the human emotion and experience that went behind it, but also because machine learning isn't creative. It can never invent new things. And I'll show you an example of that in just a moment. But looking at news articles like this one, I was inspired and I wanted to come up with an example, a perfect example of why machine learning is not meant to replace, but rather to augment creative professionals, like, for example, songwriters. And so I set out on a journey to generate AI, to generate music lyrics using the power of AI entirely automatically in collaboration with songwriters. Now, I knew from the very beginning that this was an incredibly difficult challenge. However, I decided to go about using the power of machine learning and custom deep neural networks to do it regardless. Now, there's lots of challenges, as I mentioned, right? Take a simple verse like this one, for example. Even with such a simple verse, understanding it can be incredibly complex. Just the second line requires you to have an intricate understanding of human society and the fact that humans need sleep and that sleep is important and that Tylenol is medicine that's supposed to help you sleep, but that in this case it's not working and that there's a sort of metaphorical meaning behind it. It requires you to understand so much. And then when you start doing the real data science, you realize there's even more, right? Take a verse like this one, for example. If you take a look, there's a line break, right? There's two lines over here, and the break between those lines is related to a pause in the melody of the song, right? Like those two lines form one sentence, and the break between them is because of the melody of the song. But these two lines, they're entirely different sentences. It's not just the melody that causes that break. And so there's a sort of double meaning to line breaks now. And that's something you don't just immediately think of when you take a look at music lyrics. And so there's all kinds of, really intricate things that need to be sort of understood in order to successfully generate lyrics. However, I was able to build a system that can do it. This, for example, is a verse generated by the neural network. And using any kind of classical technique, you might think that, for example, the third line makes absolutely no sense. But in the world of art, it does. You can see things with your hands in the world of, subjective art where meaning is given and isn't just inherently there, right? So because of the fact that art is so subjective and requires that creativity and requires an intricate understanding of humans, this was super complex. But I'm incredibly happy to say that I was able to work with 3 very talented artists in order to put together examples of auto lyricist in action, work together with them to create and sort of write songs with lyrics partially written by auto lyricist, my project to generate lyrics automatically, and then actually work with them on recording them singing this music. And I'd like to go ahead and show you all some clips of a song with, once again, lyrics written by auto lyricist. It's called A Summertime Song by Claudia Heuser, an incredibly talented country singer-songwriter from the USA. And I'd love to go ahead and play you all a snippet of A Summertime Song by Claudia Heuser. Let's go ahead and take a listen.
It was never my intention to unwind. Loving you is like a summertime song. It goes a blazing past. Daydreaming a feeling I can't get back. Oh, a summertime song. It's never my intention to waste your time. We jumped in the deep end and I lost what I was hoping to find. Replayed over all our favorite lines. It was never my intention to say goodbye.
And that's a snippet of A Summertime Song by Claudia Heuser. And, looking at the fact that this neural network that I created actually generated these lyrics and worked with Claudia on these lyrics is incredibly inspiring. As a matter of fact, I do want to hear Claudia's thoughts on working with the system.
When I was first approached about this, I immediately thought, no way. When we're writing songs, I really try so hard to pull from my own experiences of people in the room, and just try to be as honest as possible. So thinking about a computer coming up with these ideas for me, I wasn't really having it. But I'm always up for trying something new. And what I realized was it was almost like working with an open-minded co-writer who just brought all these ideas to the table. And yeah, you could sift through the ones that were crazy and not going to work for you, but it kind of allowed us to think a little differently and took one of these songs that we had started in a completely different direction. So we were able to come up and find the line, "Loving You is like a summertime song." And now we have a brand new song that I just love. Hope you enjoy it.
Once again, it's just so fascinating to see how Claudia went from being, a little bit apprehensive at first, thinking, do I really want to use a machine to help me write lyrics, to eventually thinking, this is a tool that can actually help me in the real world as I'm working on these music lyrics and working towards writing new music. I was also able to work with the incredibly talented Elena Coates, pop singer-songwriter, as well as James Abair, an incredible music producer, on another song called "Take You There," which I will be linking to in the live chat in a couple of minutes, as well as maybe we'll add that to the description of the replay available after the event, so you can take a look at "Take You There" by Elena and James, again with lyrics written by Auto Lyricist. However, what I would love to show you right now is just a quick snippet of Elena and James' thoughts on, once again, working with the Auto Lyricist system.
I like to write songs with other people a lot. I like that collaboration aspect of it. And I think that with this application, it would be a great tool to, generate ideas, and, you can input the lyrics that you have and the ideas that you have. And with what this program generates, I feel like you can take that and expand on it and really put your human touch on that.
I think the assumption going into it was that they might sound static or robotic. And so when I saw the lyrics that Tanmay sent, I was very impressed by how emotional and how much pathos they had, for being written by a neural network. For experienced musicians, this tool could be really useful because it effectively eliminates writer's block. You have access to an endless supply of different permutations of lyrics, that you can add your own rhythm to, add your own rhyme to, add.
And that is Auto Lyricist in action. Once again, one of these projects that I'm just so excited about because it perfectly demonstrates where machine learning should be applied. When you build entire pipelines and systems like this from the ground up with the intention of augmenting humans, you can create some genuinely valuable tools. And this brings me to the next big thing in technology, right? What do I think the next big thing in technology is? Well, there have been examples of neural networks out there and deep learning systems deployed, like, for example, OpenAI's GPT-3. This is something that practically everybody's heard of. People have been talking about it for the longest time. And when OpenAI released it, there was this huge hype, right? There was this, huge hype where every news article was basically GPT-3 will replace and then just insert profession here, right? You could say journalist, developer, business person, executive, whatever, artist. It would be replacing all of them, according to tons of different, news articles and the media generally. And really, the reason that there was this much hype is because GPT-3 is just so good at writing language, right? GPT-3 is incredibly good at taking text and extending it, right? And continuing to write its own text. However, OpenAI's GPT-3 is in no way intelligent, right? GPT-3 is not going to be used to just automatically generate novels or just automatically, write code for developers or write music, right? That's not the point of GPT-3. The fact that it's really good at writing really just makes it really good at comprehending natural language because of the inherent limitations of computers. They are not creative, and writing is an inherently creative task. While GPT-3 can take previous sets of knowledge and redistribute the words in order to come up with new ways of saying things, it cannot come up with inherently new messaging. That is the limitation with machine learning technology today. As a matter of fact, if we go back a little bit, remember this quote about machine learning and why it's so important? Well, what if I told you that this quote was actually written by GPT-3? I wrote a little prompt asking, why is machine learning such an innovative technology? And this was one of the responses it came up with, right? Barely cherry-picked, about 3 generations in. And this perfectly describes what machine learning technology is capable of, because this specific quote contains no new information. This is something that in general, you can find this message online, right? This is something that people have said, but they've never said it this exact way. This is not plagiarized in any way, right? Just because GPT-3 knows this based on previous human experience doesn't mean it's copying. This is genuinely new, but it's not a new message. There was no creativity involved in the creation and the ideation of this message. And so I think that one of the next big things in technology, apart from just technical innovation, is from an angle of technologies that I'm passionate about, like artificial intelligence, for example. We're not only going to see further technical innovations, but also user experience and understanding-based innovations, right? Innovations in the sense of people will better understand the role that this technology plays in their lives and what it's meant to do and where it's going in the future. Because today, I feel like we can barely understand where this technology is headed in a couple of years and sort of what the role is that it plays in our lives. And so we're going to start to see more and more people understand the truth behind these sorts of technologies and start to apply them the right way, right? Instead of trying to build systems that are replacing human creative professionals like songwriters and musicians, we're going to start to build useful tools that can actually augment them based on systems like, for example, my Auto Lyricists project. So that's what I think is one of the next big things in technology. Once again, I'd love to go ahead and get your thoughts and answer your questions now. But really quickly, before I do that, I do want to say one more thing, and that is that everything that I've shown you today really works towards one goal of mine, and one thing that I think we should all be doing as developers, as engineers, as people working on technology, and that is that we use technology to solve people's problems, right? At the end of the day, that is what we use technology for. We are trying to use this incredible capability that we have to apply it to solve different problems in different domains, right? That is why technology is infrastructure, and that is why machine learning is so fascinating to me, because it can solve practically any problem where we're only limited by the level of data that we can understand. And so with that, I'd love to go ahead and answer any questions you may have now. If we're unable to get to any of your questions, feel free to go ahead and contact me on any of the following social media after the fact as well. But once again, would love to go ahead and answer your questions now.
Thank you, Tanmay, for such an insightful lecture. I'm sure that I'm speaking on behalf of the entire audience watching us right now, that you have positively revealed groundbreaking thoughts and promising ideas while instilling a new perspective in our lives. We'll now begin the Q&A session to answer a few of our audience questions. Okay, so the first question is, AI cloud services or data as a service haven't been able to pace up except for a few major companies. And according to a consensus, this is mainly a data problem. So do you suggest there are ways to analyze data without compromising on privacy to see a spike in these kind of services?
That's a very interesting question, and it's simultaneously a problem with human society and culture and technology, and the way that they intertwine is simultaneously interesting but also confusing. I think there's two things to keep in mind. First of all, privacy from a technical perspective should always be best effort. Whenever there's anything that forces you to need to compromise some level of user privacy in order for a certain experience to be delivered, privacy should always be at the forefront of those decisions and should still be treated as a first-class citizen, right? Think about Apple, for example. Whenever they're implementing features that will compromise on user privacy, they do it in the most private way possible. If they're going to need to analyze recordings from Siri, or if they're going to need to scan pictures on your iPhone, for example, even if it's something that we don't want them to do, and for example, they eventually said, you know what, we're not going to scan your pictures, even if it's something we don't want them to do, they're still doing it in a much better way than anybody else is doing it, right? They're still doing it in a way that's more private. So first of all, from a technical perspective, I think that privacy should always be, first-class citizen in the sense of where it is in the pecking order of what we consider. But from a society perspective, I think there are some use cases that inherently require a certain level of sharing. And whether or not that's worth it is an individual trade-off for every user. Everybody has their own heuristics of what they prefer. Some people are going to be like, no, I really value my privacy, so I don't care if I can't use X feature, but I'm not going to use it because I don't want to give up my privacy. Some people are going to be like, you know what, I don't really care. This data, it's just a machine that's looking at it. It's being stored on this server. I'm fine if it delivers this experience. What's important, I think, is transparency, making sure you have that level of security with the data from a technical perspective, and also, enabling users to judge that trade-off accurately. I think there will be more innovative ways of getting around this problem in the future. So, for example, we have technologies like homomorphic encryption that could allow us to theoretically analyze data while it's encrypted. We could have more edge computing to make it so that things can happen on the edge. Taking a look at like the newest M1 processor and the A15 Bionic and these things, they allow us to do so much more processing on device than ever possible before. I think there's huge possibilities, but as of right now, it's more of a user experience and transparency and security issue than it is, innovating new ways to apply, for example, AI. So I think it's a combination of a bunch of different, techniques to apply.
Yeah, that was an interesting perspective. Okay, moving on. Can you tell us a bit about your healthcare project, Cognitive, and how it has impacted Boon?
Absolutely. I'd love to go ahead and share some more details. This is a project that, we're still working on actively. This is one of those projects that, is definitely long-term. So far, the milestone that we've reached is I can run electroencephalogram analysis using deep neural networks that I've trained without going into frequency domain. So looking at time domain data, I can do analysis in order to, for example, figure out simple intent like yes or no, and different mental states like relaxed and concentrating. And traditional techniques might use specifically spikes in the alpha frequency, but this is based on raw analysis using deep neural networks. It can run on mobile devices in real time. Now our next challenge to solve is to find the right hardware with which we can capture data with the right fidelity, with the right speed, and with the right sort of resolution in order to provide the neural network that I have built with more data with which to do analysis. This is, of course, an incredibly difficult challenge to solve without going into the, tens of thousands of dollars in terms of budget, and also without going into territory where the headsets look like medieval torture devices, right? Because these can be really, really annoying to wear sometimes. There are some headsets that like spike into your skin and are super uncomfortable after a few minutes. We don't want to do that, right? The point of this is to make people more comfortable. So our next challenge is to get the right hardware, something we're actively working on. If anybody has any thoughts, please do make sure to reach out to me. But it's something that we're actively working on, and we've gotten to the point of being able to recognize simple intent with the neural networks that I've trained.
Yeah, it's great to see that AI is able to assist humans in such a great way.
Thank you.
Okay, moving on. There is an interesting app of yours, Tanmay Social Media Analyzer. So can you tell us something about it?
Absolutely. I remember that T-SOMA, Tanmay Social Media Analyzer. That's one of my, earlier applications that I had built with AI, powered by Watson. It effectively enables you to look at social media posts in real time in order to do things like personality and sentiment analysis of certain topics and in general across social media. That was eventually sort of taken and integrated into an application that me and one of my mentors built. His name is Timothy Duncan. We built an application called Market Alerts that used the power of T-SOMA in order to help people make more informed decisions on their assets like stocks and crypto and things like this. And so now these days, T-SOMA-like functionality is built into a lot of different platforms that help you do analysis of social media, and I'm glad to say that this is something that more people are sort of deploying today in the real world. And so yeah, that was one of my earlier applications using artificial intelligence, and you can still find my YouTube tutorials and such that explain how to build similar systems yourself.
Okay, so the next question is, how can a beginner who is keen on learning AI and ML begin to learn it in depth?
Definitely. Machine learning and AI are, I would say they are a tool in your tool belt when it comes to solving problems, right? A lot of people have like no technical base knowledge, and a lot of them will say, hey, I want to learn machine learning first. But what I would say is that while machine learning is definitely a really important tool and it's super versatile, you should absolutely remember to give importance to the fundamental technical foundation first. So I would say before you learn machine learning, learn how to program, which, learning how to program is an entirely different question in and of itself. There's some resources I could recommend, like my books, like Hello Swift and Tanmay Teaches Julia, cognitiveclass.ai. There's Swift Playgrounds is a great application, these sorts of resources to learn how to program. And then once you've learned how to code, then I would say move into a more advanced technology like machine learning. And to learn, machine learning technology, you could start off with a resource like my book, Cognitive Computing with Watson. You could start off with cognitiveclass.ai courses. Those are great for learning machine learning. There's one called Python for Data Science and Data Science for Beginners. You might want to take a look at that one, as well as different courses on Coursera, Udemy. You can do things like Kaggle challenges, right? And the reason that I recommend this is because in general, I feel like the best way of learning is by actually doing and getting experience. So, doing things like Kaggle challenges are great, but what's even better, in my opinion, is coming up with ideas yourself, things that you want to see done, and then trying to do them. Right? Even if you're never able to fully complete it, trying to see how far you can get. I remember one of my earlier projects was trying to implement a neural network that could recognize where certain objects are in images without needing to be trained on that object detection based on classification. So I spent a good couple of weeks, training neural networks on classification and looking at the, GradCam output and trying to figure out if there's ways to localize objects without training it on detection. And I came up with a pretty good system in the end, right? And so come up with these random ideas where you're like, I wonder if that could exist, and try building them is one of the best ways. So start off with courses like those from cognitiveclass.ai. There's my YouTube channel as well. And then go ahead and move into the whole, build Kaggle projects, work on random ideas that you think would be interesting. I think that's the best way to learn, is by getting experience that way.
Yeah, I'm sure this will be very useful for the audience. Okay, and last question. It is said that you spotted a glitch in IBM's document conversion service after using it for a few minutes. So can you elaborate on this?
Sure. So the document conversion service was a pretty old Watson service. They've deprecated it now, but what it used to do was basically take a document and it would split it up into components, and these components were called answer units. And these answer units were then fed into a different Watson service that could then, take questions and determine which answer units contained answers to the question. But there was a bug where if you formatted a PDF a certain way and you fed the document conversion service with that PDF, it wouldn't actually split up the document into different answer units. It would just spit out the entire document in one answer unit. And so that really confused me back when I was 11, because I was like, shouldn't this be multiple different answer units? Why is this one? And so I remember I had posted a question on Stack Overflow saying, either I'm misunderstanding the service or there's a bug in the way that it works. And I'm pretty sure it's a bug because, it shouldn't just be one answer unit. And so, a couple IBMers actually saw that Stack Overflow post and they were like, hey, you're right. That's an issue with the way we did that. So they ended up fixing it, which was incredible, because then I used it for a couple different applications. And that's how I sort of started working with this technology, Watson and IBM's tooling. And it was a pretty fun experience.
Yeah, that was very interesting. Thank you, Tanmay. We are honored by your presence. It was indeed an impactful session. Also, thank you to our wonderful audience for tuning in. We hope you all enjoyed the session. A reminder to our audience, the next lecture in this series is the phenomenal Mr. Ajit Balakrishnan, the founder of Readit.com, on 12th October, 5:30 p.m. Be sure to attend. I am Urvi Ranjan, and until next time, this is Technovanza VJTI.